Welcome back. In this clip, we'll talk about the process of assigning the customized geometry to the particles with the help of the particle instancer. So before we start creating the effect of the particles, let me tell you one very important thing that I just, forgot to share with you. And that's something which is very simple. When we are required to use the effect of the shatter, it won't work on the object. As you can simply notice, just nothing happened because we don't have the freeze transformations. So if you just wanted to utilize the shatter, you are required to use first the freeze transformations. You can also simply get rid of the history, that is edit delete by type history, and you can simply go to the shader and use this, not a problem. All right, so just be very careful while using the shader. Make sure that everything is set to the 000. All right, now let me just get rid of this. Now we'll get to the particle systems. So over here we have the nParticles menu. We can go inside the create emitter, and let's say we are using a very simple emitter type, that is, in this case I'm using the volume. Create this, let's reposition this. Now instead of using the default as a cube volume shape, I like to go for the sphere. All right, let me just scale this a bit, and not a problem. And we just try to match this approximately with respect to this vase. You can simply scale this out and just simply transform this. All right, I have this vase object selected. Now I just wanted to utilize the visibility. So this is a kind of a cheat we are doing, but yet very effective. So as you can notice, I've already given two keys over there. So the moment particle reaches the value of 35, and the moment it tries to shift to the next frame, you can see the visibility of that vase just simply disappears because I have keyed the visibility. All right, so we are going to use the same thing, and let's just do one thing. Let's select the vase, go inside the object display, and for the time let's use the intermediate object. All right, now let me just use the rate to the proper timings. We have the keys at frame 34 and 35. So let's do one thing. Let's bring down the rate to the value of 0. Put a key in the first frame. Now let's move to the frame 35th, and let's again use a value of 0. At frame 36 we can use a value of, let's say, 500. Put a key over here, and let's say the effect goes for the frame 40. Hit a key, and then at frame 41, let's say we are again making the rate to the 0. So this way we can control the particle emissions. All right, because they just appears and just simply they are getting stopped. It's not simply a kind of continuous emission of the particles. So we can select the vase and can bring them back. All right, now let's do one thing. Let's also configure the various attributes with respect to the speed and the overall look and feel. So right now I'm also going to utilize the nucleus, and let me use the ground plane so that we can have the particles bounce as well as they can stay upon the ground. They shouldn't be falling down. All right, and let's also increase the substeps to a value of, let's say, 15, and put a 10 for the iteration, so this can improve the simulations. And let's do one thing. Let's increase the away from center with a value of maybe 25, away from axis to the value of 0, and let's say we want to give some vertical push, so we can use the along axis to a value of 8. And lastly, we have the random directions. We can use a value of 10. So now if I play the timeline, you can notice the particles are they are getting simply emitted from this emitter, but the problem is that the physics is not up to the mark. I mean to say that the physics is not looking as much real. It's something seems to be like we are working in a very big units. Well, this is actually the case. I'll show you with one thing. Let's say we have the measure tool, we have the distance tool. Let me go inside the side view, press the X, one click and one click. So approximately right now the length of this vase is 7 centimeter. But the moment we click to the particle system, the nucleus dynamics of Maya is considering this height not as a 7 centimeter but 7 meters. Yes, it's considering this as a 7 meter, and the simulation of the particles is now inside the metric units. We have 9.8 meter per second gravity. All right, so these particles are simply behaving like they are inside the metric units, because inside the nucleus dynamics we have a very important concept, that is the scale, that is the space scale. So space scale of 1 is equivalent to 1 metric units. So that means whatever object we create inside the Maya, let's say if the object is of the size 10 centimeter units. So the size is very important inside this nucleus dynamics. Let's say we have an object of 10 centimeter. So the nucleus object will treat that 10 centimeter object as a 10 meters. So there is a solution, it's not a problem. We can just simply dip down this thing, here the space scale 1 is equivalent to 1 meter. So everybody knows that 1 meter carries 100 centimeters. So instead of bringing this value to the 0.01, what I can do, I can just dip down the value. Let's say we can use the value of maybe 0.1, or let's say 0.25. So this way we are, decreasing the space scale. And now if I play the timeline, you'll see your particles will behave significantly in a little bit different manner. Now you can see particles are simply colliding, and the particles are simply, getting influenced with the gravity with a much higher velocities, and they are simply, coming down to coming down back to the surface with lesser amount of the time. But notice one thing, what if I have the nucleus value set to the 1, and now you notice that the particles, will take longer amount of the time to get them back to the surface, and that is something not, good, because it simply indicates that we are working in a very large space scale. So that thing is very important. So bring this thing back to the 0.25, maybe 0.2, whichever way you want, and that's something very nice, right? So we are good to go. Now it's time to create the particle instancer. That's a very simple process. You're required to select all these pieces of this debris or the polygon shell, and we can go inside the nParticles menu. Over here we have the instancer. Move inside the option box and make sure that you also enable the allow all data type. This attribute means that, for example, you are required to use some customized PP attributes, per particle attributes. They can be of the type vector, scalar, integer. So it ensures that you can use all kind of the data type, be it vector, be it scalar, be it a float, be it an integer. All right. Now with this, make sure that if in your scene you're having more than 2 or 3 particles set, so you have to assign your instancer to a particular particle set. In this case, we are having only one particle. That's why it is showing me only nParticle shape 1. All right. Now if you have selected everything, hit the option create. The moment you create this, you'll notice that all the particles are right now showing me the one type of a particle instance. So that means all these pieces of debris are exactly the same. So we'll configure a method to randomize them, because right now the Maya is just picking the first object, that is, that is this one, and you can see it is absolutely similar to all of them. So we are required to randomize these choice. We are required that Maya should randomize the choice of the instancer, so that every particle should has its own different, geometry. So let's first do one thing. Let's just hide this, instancer polygon mesh. Let's go inside the nParticle 1. I assign a simple custom attribute to this. Let's say we can go inside the per particle attributes, and let's, close the shading. Inside the add dynamic properties, inside the add dynamic attribute, move inside the general, and let's say we pick the per particles, and we have the data type set to the float my underscore shape. All right, we can just name anything we want. Hit the OK. Now inside my shape, you can go for the create expressions. Now in the creation mode, we can utilize this with a random function. Let's say we have random with a value of maybe 1 by 15. So I really don't remember how many particles we have. So, and that's sorry is equals to the ran, hit the option create. Now we have approximately 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Very nice, we have absolutely 15 objects. All right, no problem. Now let's do one thing. Let's go to the particle node, particle shape node. Over here we have the instancer. So this is basically the big section for the instancer. So you can right now, simply enable this, allow all data type. And the most important attribute for this case is the object index, the object ID. You can click this and change the attribute type to the my shape, which is the customized attribute we have. Now, if you play your timeline, you'll notice a big change. Now you're seeing all these particles are showing the different, instances. But yes, I do acknowledge the physics is totally bad and the particle size is a way too much big. So we are simply required to fix all this kind of a mess. So for that, we are required to use the custom scale, custom spin, custom rotations, and few more things. So let's do one thing. Let's take a pause from this clip. In the next clip, we'll talk about the randomizations with respect to the scale, rotation, and the spinning of the particles. All right, so see you there in the next clip.